And welcome back. As I was looking for our next subject to study, I couldn't decide between a JavaScript program or a Haskell program, so I decided to do a little bit of both. We're going to take a look at Fay, which is a language that's like Haskell. In fact, it's a subset of Haskell. And Fay itself is written in both Haskell and JavaScript. So why Fay rather than one of the other dozen or more functional languages that compile to JavaScript? Well, primarily because it seems to be the most popular and is being actively worked on. Also, since it's a subset of Haskell, you don't need to learn a new language, although you are going to have to learn which parts you can use and how to use a foreign function interface. And why Fay and other languages that compile to JavaScript in general? You're probably already familiar with it, but well, if you've built a large JavaScript program or even a smaller one, you may have gotten tired of having to debug errors at runtime, and it's nice to be able to detect certain errors at compile time. There may be some other reasons for using it, but for me that's the most important. Now, like usual, we're going to start by checking out the code from GitHub. And we'll be working with version, let's see, 0.14, which is the latest tagged release in the Git repository. And as usual, to keep things simple, we'll be using Cabal Dev. And Fay specifically has Cabal Dev support in it. So this will probably take a little while. Wow, that was a lot of dependencies, but it's finally done. Well, almost. Fay is distributed in parts. This is the compiler, but some of the basic library functions are distributed in another repository called Fay Base, I believe. Here we are, Fay Base. So we're going to build that as well. And I'm just going to check this out into the Fay directory itself and build it there. We're going to want to build these in the same Cabal Dev environment. So to do that, first let's check out the same tag for Fay Base, which tracks the main Fay. Then let's link the parent repository's Cabal Dev directory here. And finally, let's build this as well. That was a lot faster. I suppose you could check this out into the sandbox directory itself or a higher level directory and symbolically link things, but this is what made sense to me. And now let's test Fay by building a simple program with it, like a hello world program. The first thing you need to do is create a Haskell file. Now this isn't technically Haskell, it's a subset of Haskell defined by Fay, but we'll just use the extension so we get syntax highlighting. And import the prelude, which is a modified version of Haskell's prelude, or at least you can think about it that way. We'll define a main function and write out hello world. And now to test it, we'll compile it with Fay. So let's get back into the directory we saved the file in, and then call Fay Cabal Dev bin Fay on test.hs. And we got an error, and this is because we're using Fay from Cabal Dev, and the solution to that is documented on the Fay wiki under installing and running. What we need to do is export this Haskell package sandbox variable. So let's do that. And it's going to be the directory that we have Cabal dev in. And now let's try again. Oops, I've got the sandbox wrong. It actually wants this packages conf directory. So we'll try it again. And now there is a test.js. Now, I suppose you could test this on the command line with a JavaScript engine, but I only write JavaScript for the browser, so I'm going to go ahead and create an HTML file, and let's see, Fay test. We can remove all this, and let's include the JavaScript, test.js. And then we can test that out in Firefox. And we don't see anything, and that's because the output is sent to the console. So let's reload the page. And there it is, hello world. Now, before we take a look at a more interesting example, let's peek at the JavaScript that Fay is generating in test.js. First, there's this main wrapper function. And immediately below it, the Fay JavaScript runtime begins. You can take a look at this in the file fay.js runtime.js. That's this file here. And it looks like it's some 600 lines. So skipping past that, we get into this application code here. And this isn't actually just our application. This is a combination of the prelude that we imported, as well as at the end of it, our application code. And to find that, I'm just going to search for the string hello, and you can see main declared here, and then some more code after it. And at the end of the file, the main wrapper is instantiated, and then the main tucked away inside that is called. And there's a lot of dollar signs everywhere. Don't worry about the details yet. We're just getting a feel for things. Now, our test is really simple, and I don't think that will really show off what's happening. So let's try a more complicated example. And fortunately, Fay includes some in the repository itself. So we'll run Fay again. And this time I'm going to use the pretty option, which will keep the code from getting all concatenated together without spaces like you saw. And we'll run it on Fay examples canvaswater.hs. And you get these errors because there was a change to Fay between when they were written and the current version we're using, and the examples weren't updated. So I'll show you what you need to do briefly. Fay examples canvaswater.hs. So all you need to do is eliminate any instances of the class foreign. So here, here, here. Hopefully there's not too many of these places. Don't need that. Okay. And it looks like that's all of them. So let's go ahead and try again. And it worked. Or at least I hope it worked. Let's test in Firefox. So Firefox, Fay. Each of the examples comes with an HTML file. And there it is. So let's see if we can see what's going on here by looking at the Fay or Haskell source and comparing it with the generated JavaScript. And I'm just going to split the windows so we can look at both at once. Why don't we start by looking at the first function apart from main called start. In the JavaScript it should have the same name. and here it is. And if we look at this function long enough in both languages, we can start to see the similarities between them. But before we do that, let's just make sure we understand what's happening on the Fay or Haskell side. So start is a function of one argument in the Fay monad. And the Fay monad is a way of sequencing actions. You can think of it like the IO monad for now. So it gets the canvas element by ID, which if we look at the HTML, let's see, canvaswater.html is what you'd expect. There is an element with ID can. It gets a context for the canvas, a 2D drawing context, draws an image, and then sets up a variable reference, which is sort of like an IO reference if you're familiar with that, and then sets a timer to animate. We'll get into what exactly this means later, but for now, all that you really need to see is that there are some actions in a monad in this function. Monads aren't as complicated as you'd expect if you're not familiar with them. They're essentially a way of sequencing actions, or at least we can think of them that way for now, because that's what the Fay monad is doing here. And it might be a little bit easier to see what's going on if we just change how this function is written a little bit, using explicit bind and anonymous functions. So this get context gives us a context variable, and so on. And you can see this sort of nesting even more clearly if you replace these P1 or first parameter variables here. I'm not sure why they are done this way in Fay. Maybe there's some good reason I'm not aware of. And now if you look at this, you can start to see the similarities more clearly. First, there's a call to get element by ID, and that result is passed into an anonymous function that takes a canvas value, which then calls get context, and so on. This draw image doesn't actually return a value in the monad. This would be written like this, and you can see here in the Fay code, let's replace this as well here with context, that draw image with the arguments here ending with the last 0, instead of being called on an anonymous function that takes a parameter, it just calls this other block of code here, which is the next part that sets up a step reference. And so we could kind of visualize this like this. So step, and then the final action in the monad here. Oh. Now what may still be a little bit confusing about this is these calls to Fay $_ and Fay $_ bind. So let's look up at the top of the file, and Fay $_ is actually the first function in the Fay JavaScript runtime. And the comment says that it forces a thunk into WHNF, which is weak head normal form. This is the kind of terminology that you'll find if you look at how GHC implements non-strict Haskell semantics. It does it by using a lazy implementation, and it uses thunks. And forcing a thunk into weak head normal form is basically evaluating it. And if you want to see some more about that, I covered it a little bit in the second part of the look at Xmonad source code, which I believe was episode 4 of Code Deconstructed. We are going to take a look at how these thunks work, but I think that starting it right now would make this episode a little bit too long, so I'll save that for the next one. Thanks for watching, and I'll see you soon.